Oh, there we go. So Ivan, here's what we're gonna do. We're gonna graph this one right here. We're gonna find all of this stuff, and then we're gonna make our graph, right? So for the x-intercepts, we put a 0 for y, and then we solve. That doesn't look like it's factorable. Like, I don't even care. I'm not even gonna try, because I can't think of factors of 35 that add to 3, so I don't think it's factorable. So I'm going to use a quadratic formula. So because it seems like we're forgetting everything today, I think it's a good idea to write it down, right?
So that parabola is going to go down, right?
Simon Limon. Leading coefficient's negative, it's going to go down. That's right. Okay, let's see. Are we good with this? Negative 3 plus or minus the square root of 9 minus 4 times negative 5 times negative 7, 2 times negative 5. We good with all that?
So why are we doing this and not doing it the other way?
Because we can't factor it. It's not factorable.
Oh, it's not factorable?
Yeah, so that's what we're going to do. Check this out right here. You see that thing right there? If that's negative, there's no x-intercepts. It's imaginary. If that part that I highlighted is negative, it's imaginary. 5 times 4 times 7, is that 140? That's a little bigger than 9, huh? And it's negative. So that part right there, just that part right there is highlighted, right? That part right there is 9 minus 140. That's negative. That means that you have the square root of a negative number. It's imaginary. That means there's no x-intercepts.
What? Why 9 minus 4?
Because that's 140.
So you're not subtracting 9 minus 4? You're multiplying.
No, order of operations. You have to multiply all those together. Yeah? Okay. So based on, yeah.
If
yes.
That part
yes.
Is what? Is negative?
Yeah, then there's no x-intercepts. It's imaginary.
So there has to be the number inside the box, right? For that.
What do you?
For that to happen.
That
for it to be no x-intercepts.
So if there's no x-intercepts, the square root, it's going to be a negative number inside the square root. Negative square roots are imaginary. Now if this was 0, there would be 1, exactly 1. If this was a square root of 0, when you were done, it would be 1 answer. 1 x-intercept. So Alexa, let's see. Check this out, Alexa, because you said this is going down, and I agree. And there's no x-intercepts. Here's what I know it's going to look like. Like, just generally. It's going to look something like this. Because there's no x-intercepts and it's going down. That means the vertex is going to be underneath the x-axis, right? And it's going down because it's negative leading coefficient. It's going to look something like that. Okay. Let's find the y-intercept. Would you guys agree with me that the y-intercept is negative 7?
Yes.
Okay. Now the vertex is ugly on this one. It is. What's your question, Alexa?
Yeah.
You sure?
Yeah.
Okay. So the vertex, here's what we're going to do. Let's not write it the way we wrote it a minute ago because the function notation confused you. And we can just do it like this. It means the same thing, and we'll get to functions later. Okay, so negative b over 2a. So that's going to be negative 3 over 2 times negative 5. Would you agree? And that is 3/10. Are we good? Edgar, there's a pattern when you plug this number back into here. Even if it's a fraction, there's a pattern. It works out the same way every time. Do you remember how when we were completing the square, there's a pattern and works the same way even though the numbers looked ugly?
Yeah.
It's a different pattern, but it's similar for this. So this is an ugly fraction.
What to the left?
Well, watch. This is a similar pattern, even though this is an ugly fraction. So what we got to do So after you find the x, the way you find the y, right, is you plug this value in. Right. So here's what we're going to get. We're going to get y equals -5 3/10 squared plus 3 times 3/10 minus 7. Because all of this is the vertex, right? All of that, and then all of that. That's what we're doing, finding the vertex. Okay. Order of operations says you have to square before you reduce. You can reduce 5 and 10, but you have to square it first. So this is going to be 9 over 100. -5 times 9 over 100. Would you agree with me? And this is going to be plus 9 over 10 minus 7. I'll say when you have to do these on a test, there's not going to be very many. There's a lot of work, so you got to take your time. Well, there's not going to be very many of them. So
well, that's a good.
It's good and it's bad. You know why?
Why?
Well, because if you look at it and you go, oh, I can't do the fraction, and you don't do it, then like if there's 2 problems, you get a 50.
Because they're worth a lot, these?
Yeah. Yeah. So Alexa, check this out. We can reduce this. Now, first of all, negative times a positive will be negative, right? So it's going to be negative. And 5 and 100, isn't that 20? Okay. Oh, dang it. That's -7. I'm sorry.
Okay, where does it get 9 and 20 from?
5 and 100 reduces to 1 and 20.
1 and 20?
Yeah, 5 goes into 5 one time, and 1 times 9 is 9. And 5 goes into 100 20 times.
Okay.
Like, okay, here's the thing. Do you see these numbers? These two right here? Ivan, you see these 2 numbers? Here's the pattern. And this is what makes this easy. They're always, this one, don't worry about the sign, but this one's always, it's always actually twice as big as that one. If you're dividing by 10 versus dividing by 20, that's twice as big. Like, it's always going to be twice as big. So here's what we got. If we get a common denominator, here's what we got. You see? All you gotta do is multiply by 2 over 2, right? It's always twice as big. And then that's going to be positive 9 over 20 minus 7. That's going to be -6 and 11/20. I know, fractions, right? Telling you. I'm telling you. And that's not even a hard fraction. That's a whole number minus a fraction that's less than 1.
Oh, c'est cierto, that's right.
What?
You're just subtracting 9 from 18, right?
Right here?
Yeah.
Yeah.
That's a positive sign?
Yeah, that's how I got that. Yeah, because that's 9 minus 18 is positive 9, and then, yeah, the 20 stays the same. So then 9 out of 20 minus 7 is, yeah. Watch this, Alexa. Let's see if I can make this a little easier for you. Ready? What if you're going to do 5 minus a quarter? So you have $5, you spend 25 cents. Don't you have $4.75 left? Hi, Alexa. How are you? Alexa, imagine you had $5 and you spent 25 cents, a quarter, right?
Yeah.
How much money would you have left if you started with $5 and you spent a quarter?
$4.75.
$4.75, $4.75, right?
Yeah.
If you had $5 and you spent a quarter, you'd have $4.75 left. Because that quarter gets taken away from one of the whole dollars. That's $1 and $4. That's how you get $5, right?
Mm-hmm.
Right, and that $1 is 4 out of 4. And you're going to spend 1 out of 4, and that's how that 1 becomes 3 out of 4.
I do get that.
That's the same thing here. Mira, Masha. 7, right? 7, wouldn't 7 be 6 plus 1? Right? And if we're going to talk about a denominator of 20, wouldn't that be 7 plus 20 over 20? Right? And if you're going to subtract 9 out of 20, doesn't that give you 6 and 11 out of 20? Because 20 minus 9 is 11.
20 minus 9 is 11?
Yeah. I hope. Is it? I think so. And then the only other thing is that you have to be careful of the signs. 7 is going to be, it's negative, so it's, yeah. But you can do all that in your head. You can do all that in your head. So the problem is you're looking at steps instead of just like seeing them as numbers. All right. All that aside, Mr. Flowers, you ready? Let's graph this, and then we're going to, whoa, wait, we can find the range right now. Because you see, it's going down. Oh, sorry. You can't see. There we go. I'm sorry. That's going down, right? And that means that this is the highest point. So the range is from negative infinity to negative 6 and 11/20. That's our range.
Isn't it going to be negative infinity to 3 over 10?
No, because range is the output. It's the y, not the x. Yep. Edgar, to graph this one, you have to use your line of symmetry, I think.
Why exactly though?
Why? Because you only have 2 points.
Oh.
Yeah. I mean, we could plug in numbers and come up with other coordinates, but it's just a sketch of a graph. It's rough.
Why is that a negative infinity and not a positive?
Because it's going down.
Oh, okay.
Right?
So if it was going up, it
Yeah.
would be positive?
Then it would be this to positive infinity. You see how that works? Okay.
Are we gonna have like ones hard like this one?
Well, yeah.
Or this one was very hard?
This is very hard. Like, you're not gonna see one that's more difficult than this. Like, you won't. And so here's the expectation. To get a good grade, you have to be able to try all this. Like, if you make a mistake, like a adding mistake or a multiplication mistake or a sign error, that's fine. It's no big deal. But if you like don't know how to work your way through these problems, then you don't know what you need for the next class.
It's just knowing how to do the steps.
Yeah. Yeah. If you understand how to do them, then and you mess up doing it, but you understand what you're doing, that's fine. I mean, we mess up. Like I messed up a really silly thing a minute ago. Remember? It's because I put the wrong number on the top and the bottom, and there's no way to mess that. I shouldn't mess that up. That's dumb. It happens. Okay. Here's the points, right? No x-intercepts. 0, -7. That's right here. Okay. And then 3/10. Here's our vertex. Right? 3/10 is about a third. So if that's 1, 3/10 would be somewhere over here, right? Hey Ivan, do you see how I'm drawing my line of symmetry before I drew the vertex?
Yeah.
Yeah, you see. Do you know how I did that?
Hmm?
Do you know how I did that? You know how I drew this before I did the vertex?
I know how you did that and why you did
You
that.
did the 3/10.
Yeah, because the line of symmetry goes through the x part of the vertex. So my vertex is going to be somewhere on this line. It's going to be -6 and 11/20. So to be smart, the thing I really should have done when I put this on here, I should write my coordinate. Especially since I don't have numbers on it, right? So is this number right here above this or below it? Is it closer to the x-axis or underneath it?
It's underneath.
No, it's above it. Because this would be -6 right there, right? And then -5 and -4, right? And this is -6 and almost a half, so it's going to be like right there. That's -6. Sorry, that's 3/10 and -6 and 11/20. That's right there. That's the vertex. So our line of symmetry tells me I got another point like that, and then draw your graph, and you're done. That's it. It's a lot to put together, huh? Yeah. Definitely the most complicated thing that we've done.
I need to work on my drawing skills.
Because you know, because you have to be able to solve a quadratic equation, which means you have to be good at factoring, or you have to be good at the quadratic formula, or both, right? You have to know the vertex formula. You have fractions. You have a lot of things to keep track of. That's why Alexa's really excited about this lesson. Oh, whoa. Okay. Here, let's try one. You want to do an easy one?
Yes.
Okay. Let's do this one. Why don't you graph y equals? We'll make it factorable. So why don't you try that one?